Hello, welcome to episode 162 in this series where I am programming an NES game live on Twitch from scratch. Let's get right into things here. So, one of the things we have accomplished here very nicely is we actually have the game map and repeat scrolling modes working in the appropriate way where we can transition between them, and they transition and everything works the way that we want it to. One little nit that I had from last time is you'll notice that when the game starts up, I don't know if you can see it in the video or not, but there's if I slow down the emulation, you can definitely see there's a little moment where the title screen is still visible, and it causes a moment of that to show up before we jump to the map. So let's do two things. Let's add a couple subroutines here for turning the screen, for turning rendering on and off. And these should just be pretty straightforward. I believe we are just going to unset a few bits in 2000 and actually just register 2000, I think. No, no, in 2001. Okay, so we're not doing any sort of any modes with the PPU mask that we need to remember. So basically what we'll just be able to do is we'll be able to do a simple load of we're going to turn off color emphasis for blue, green, and red. This is to disable, so we're going to turn off sprite rendering. And we're going to turn off background rendering. Looks like this is just going to be 0. Alright, so that's just going to turn off the rendering. And then in this case, we want to, where are there, 3 bits, and then we're going to turn sprite rendering on and background rendering on, and then the rest is 0. So store it 2001. Let's just look and see if we have any other places where we're doing anything like this. So it looks like we're actually doing that here. Why are we zeroing out 2000? Well, and we also probably shouldn't be doing this here only because we don't necessarily always want to do this. That could actually be what's causing that little blip that we're seeing when switching between the scrolling and the repeat scroll, or the regular map and the repeat scroll. So let's get rid of that. We will what am I doing here? NMI enabled. Oh, I guess we should probably turn off NMI. All right, so you know what? I take that back. We do want to change PPU control to turn off NMI and do the background, change the background tile select just in case. we eventually want to do something with that. I'm not too concerned with that, but then let's change this to get rid of this. And what we'll do is when we go outside of, when we're dealing with actually loading the level and stuff like that, we can mess with the settings however we need to. So in this case, we're turning NMI on, and then what's S? Sprite tile select and name table select, and then I'm just going to call, right, this is just, yeah, it's just JSR disable rendering. We need to include that. I apologize for the streams being kind of erratic a little bit with the timing, only because it's been a little bit challenging with work and other things going on. I just hadn't had the time to kind of get my act together. And I guess we want sprite left column enabled all and background. Okay. I hadn't had the time to kind of get my act together enough to stream properly, just because I have had a lot going on for work and life in general. So it was just a little bit challenging to then also stream. So that's why we're doing it today. Load new game state. This is disabling rendering. Okay, so what is this doing? Load title screen. This is enabling. Okay. What is this? Process game. Oh, this was, we can leave that. That was just something I was trying based on some, something that Brad Smith had been doing to try and see like how much time we were taking up with our loop as the screen was rendering. And you can do that with the color emphasis bit, where it will actually turn the portion of the screen that you're drawing at the time, it'll change it with the color emphasis to kind of get a visual indicator of how much time it's taking per frame for your main game loop to render, or process rather. So I was just kind of testing that out to see how that works. Alright, so this is zeroing everything out. In the beginning, we don't want to call the subroutine here because the stack hasn't been set up. So let's see here. Hexadecimal digit expected. What did I do? Yeah, that was supposed to be that. And then load level. No, sorry. Load JSR load level. So there's going to be a time and a place for, yeah, so like you have to enable the rendering to have the NMI. Oh, actually, I don't know. For VBlank, maybe you don't have to, because I think, let's see, what does that say? So VBlank is probably not tied to NMI directly, that bit. Because what I was thinking is we could turn turn it on once we're in the vertical blank. And then we get a clean frame. All right, we'll try that. See how that looks. So this is loading the level. This, we don't want to do anything with the rendering here because we're in the process of, we've already got stuff on screen. So let's see if this made things look better or worse. Okay, so that actually seemed better to me in terms of not showing the title screen. Oh, no, it still did it. So is that down to, that could be down to now the fact that we have the scroll up here before we actually load the level. But what's weird about that is that we are, where are we calling this? We're calling this here. We're disabling rendering. We're waiting for a v-blank, and then we load the level. So when it calls the load level, it's just loading everything up. And rendering was disabled. Do I need to do this even slower to see what the emulator is doing? And I mean, I'm pretty sure I saw this on my real, on the TV and my real system too. So what's interesting about this is that scrolling is like kind of all over the place. That scroll box, I mean. Where do we set the scroll registers? We probably set them... Are we doing this all in the NMI? It's processing in the title screen. Yep, it looks like this is all done in the NMI. So what we probably want to do is in load level, we probably do want to set the scroll registers Are we not using that for process scrolling? That does that in... Really, where does it do that? Where is it set? Oh, you know what? We don't really change scroll scroll X ever. So this, okay, so this is resetting the scroll Y here, and then we're changing it there. Okay, I forgot, we're not moving horizontally, so that wouldn't have any impact. But scroll Y, so we are setting this to be 1. which doesn't really make a lot of sense. And then later in process game. Oh no, it does make sense because we're setting it up to process. Yeah, okay. So the scroll itself is independent of the camera position. And so we're setting it to 1 because we know that that's what it technically needs to be. But we're also... there's a bit that needs to be set to force the scroll to the next... from here to here, from the upper name table to the lower one. So that would be in PBU control in 2000. So what we probably want to do is we want to set the value to reflect that we know that if we're doing a full screen load, it should push the scroll to the bottom. So it's just 100. The rest of the stuff can be zeroed out because that's what we kind of wanted anyway. What is the bit that's an S? Guess we should be consistent with that. Why is this setting this here? Done loading tiles. So we really don't need to do this again. Load a title screen. That's fine because we want the upper name table for the title screen. That's our reset code. And what is this? Clear the register before resetting because we are in vblank. Should we be doing this everywhere or only in the NMI? I don't remember. This comment would indicate that we only need to do it in the NMI, but we'll see. Header overflows. Oh. All right. Well, that's not right. So we know things are okay up until we go to load the level. Let's take a look at what's going on. Load level. If 0 blanks and redraws the whole screen. So it only should be calling this. And that sets these two things. NMI is disabled. And rendering should also be disabled. Yeah, disabled rendering. So we load the level, we wait for VBlank, and then we enable. And here we're not doing any of that stuff. So we're not getting to that part even yet. We're in load new level, calling load level. And the first time through, we're clearing out stuff, so it should just be... Let's see if this actually matters. Oops. For here, now that we've changed some things around, it could have been just one of those situations where it just happened to work, but we should have been doing this in the first place. Nope. Alright, so why... How would that have affected rendering? Is it because we're doing something with A that we need to preserve? Story game state, no. Just want to make sure that we're not hitting a situation where we're somehow changing A and it needs to be maintained. No, that looks fine. Alright, well, let's take it to the debugger and see what's going on. It's a little bit weird that was the end result of that change, but we'll find out in a second what happened. Okay. All right. Hope everybody's having an excellent weekend. An excellent weekend, I should say, and getting to do some fun things. Enjoying potentially good weather. It's been a little bit cold here, but I don't mind that so much. I'm basically just looking to see if anything bizarre is going on, you know, versus the expected code flow. But everything there looks fine. Oh, you know what I just noticed? I don't think that's causing the problem, but that's not right. Because the other code is in that segment. Okay. I didn't think that would be it, but what's really bizarre about this is, I mean, besides everything, let me take a look at the PPE registers. NMI isn't enabled. Why is that? Did I mess up my enable rendering code? Looks like I might have. Oh no. That's in 2000, so we're turning it back on, right? We're turning it off here. Oh, we're not turning... In NMI we are, but we're not... Okay, so that's the problem, or that's part of the problem, is that we're not turning NMI back on. So... so load full screen. Should probably turn that back. Wow, but we're not ready for that yet. So it's... Should I be doing it over here? And load new game? I guess so. And then load A. NMI enabled. Zero, zero. 01 0 I recall that this was, where was this set? So this is our basic, these are our basic flags that we want. Which is NMI enabled and the background's tile select. I'm going to do that here. So that was the issue, is that NMI was off, or at least an issue. Certainly wouldn't help things for us. But this is still screwed up. I mean, it's not as bad as before. It actually is scrolling. But the palette is all wrong. And the tiles are all wrong. If we look at the character set, why is there this garbage in our character RAM? Where are we loading up the character RAM with the tiles? I think it's right in the beginning of the game. Actually, is this gonna work? Yeah, that'll work, because those are there. Why? Set 00 to 2006 and then just start writing those out. I mean, that all looks fine. Let's go to that code. How did this change make that break? That's really bizarre. So we're setting that to 0. You can see there's nothing in the character RAM. It's just got junk in it right now. So we're going to start filling the character RAM with the data from the tiles that we have. Right, so that would just be, you just keep looping to do that. Okay, so that's good. So everything looks fine up until that point. I guess we must be corrupting something somewhere. The title screen stuff looks fine. How would we be doing that? How the heck did that break that? Disable rendering. Is it actually disabling everything that it should be? I guess not. No, it's probably just turning off. Did I close the page? It's turning off this stuff, but it's not also turning off NMI, which I guess it should be. But the problem is now we got to start keeping track of like what the control of mask should be, which I guess it's not a bad thing to keep track of, but at the same point we didn't have to before. Although right now we're not really doing anything out of the ordinary. Like, it's consistent across the board. Yeah, don't be dumb. So let's just force that read there too. And then we know we want to enable NMI, and we want to enable the appropriate background bank here. So that's fine. There was a spot where we were, was it in load level? We can get rid of this because we disabled it with disabling the rendering if we need to. This can go away because enable rendering should do that. That's the actual rendering stuff. That's the reset. This is NMI code. Okay. So in the main game, we don't ever actually do, once the level has initialized, we don't disable the rendering. So hopefully that fixes it. Yeah, okay. So now I wasn't paying attention. Let's see if that fixed the title screen weirdness. No, it didn't. That's... Explain yourself. How is that? Don't worry about that part. Why? I don't get that. Like we've got the title screen, we're going through, we're loading the map, we're forcing the scroll to be based off the bottom. Oh, but we don't ever actually set the scroll register. I guess we should do that. When we're initializing the game, like, right, so we'll reset the scroll registers to the appropriate location before anything gets turned on, because I think what's happening is we're turning it on and we have everything initialized properly, but the scroll registers never get set until the NMI. So we've got probably at least a frame where it's wrong. Get out of here. Tell me I didn't build this and reload it properly, because that doesn't make any sense. I'm gonna move past this if I can't get this working with this change, because it's driving me crazy. But I also just wasted too long on this. That is bizarre. Is it because of this is the title screen process, but we're doing a new game? This can be a bit... This is in processing the scrolling, which this is fine. This is the interrupt handler, which isn't used. This is commented out. So load a scroll X, like after we come out of load level, this should all be set up okay. Oh, but you know what? There is one thing. So when we turn on rendering, this bit is not set, and that bit is the background, or is it that? Oh, sorry. Increment mode. So sprite tile select, and then this should be 1, right? Or am I looking at? I know in NMI we're modifying this and swap is either going to be swap is either going to be, what is swap going to be? Swap is going to be the second bit or 0. So what we really, I guess, want to be able to do is be able to determine if this should be this or that or some other bit. Now, let's just test this and see if that fixes it. Yep. All right, so I know it's a little thing, but it like really annoyed me that that was happening, and obviously it took too long to solve that. Now, I'm tempted to probably want to be able to pass a parameter that lets you set the bit, because we don't necessarily want we may not want this every time, but for now, let me put a note here. This always sets the scroll registers to the bottom name table, since that's how a fully loaded map would need it. Alright, so let's go back to reload this, and let's go to full speed, and yeah, it just pops in and you don't get the weird ghost title screen that you did before. Alright, sorry, that took way longer than it should have, I feel like, but it was kind of a weird culmination of a few different things that that were not working properly, and then I also went down the road of actually being able to turn the rendering off for when we're starting, so that the stuff that shows up just shows up. It's not gonna, you're not gonna see it like flicker into existence, which is always a good thing. So where I'm kind of at right now is I'm not sure what I should tackle. Like, part of me wants to work more on getting the level design stuff working better. Like the repeat scroll mode, it works, but if we zip past this here for a minute. And one thing I'm going to do here soon is I'm going to get a real NES set up for us to like do some hardware testing for some of this stuff. But yeah, so repeat scroll mode, it's it's obviously repeated, and while it's efficient, that obviously does not look great because it's too repetitive. So I'm wondering if we want to open this up to allow for like a meta tile. Where it's really, instead of just being this one 4x4, you can specify a set of 2x2 meta tiles. But even that's probably going to be too repetitive. So maybe what we want to do is we want to have something where, I don't know. We do something where there's some sort of, like, it's almost like a distribution of saying, you know, I mean, we're not going to do any like heavy calculation here, because this is, the whole point of this is to be cheap and easy. So what I'm thinking is, like, we have some sort of way of, I don't necessarily want it to be random because that presents its own set of problems. Because random means that we can't repeat it, which means that we may get weird. Let's say we're going to do something with like a grass pattern that may then yield a grass pattern that looks weird. But at the same time, I don't know. Like I don't think we're going to be using this for something like a city block or something where we want, obviously it's not going to be for something where we have a lot of detail, and so maybe the randomness is okay because it'll kind of make it look interesting. And then also it will get rid of this excuse me, it'll get rid of the obvious repetition. Now, if I remember right, there was a pretty decent, like, pseudo-random number generator here that was on offer. And basically, really all I want is something that will give us a number that will tell us if we should or shouldn't draw our repeat scroll tile. So let's see. Linear feedback shift register is commonly used as a programmatic random number generator on systems like the 6502, which have no hardware multiply. Oh, that's not a bad idea. So put together a bunch of like pre-made sections that we could just swap in and out. Or use randomly that would fit together nicely. I mean, the thing is, then that expands the scope of what we have to do with the repeat scroll, right? Because the repeat scroll right now just uses the one meta tile. And what you're suggesting would, well, I guess it would still work because you would just specify, you'd have a set of your tiles and you would, and then you'd use the random number generator to kind of read through those tiles. Yeah, possibly. Could even do down to like tile strips. Well, let's try this and see how this works. We'll mess with this tonight, and then, and then if this isn't good, we can come up with a different strategy. So let's see. This rotates a series of bits, with the bit coming off the end of the series feeding back into the register as an exclusive for operation. By choosing the feedback bits carefully, this can create a sequence that fills the register with every possible value except for 0, allowing relatively long random number sequences using only bitwise operators. Okay. So this requires a 2-byte value called the seed. All right, let's use this. And Miralupa, that's a good idea. I think we'll probably end up revisiting this pretty quickly, but right now I just don't want it to be quite so repetitive. Oops. It may be that this ends up not looking anywhere close to what I want it to, and so we'll take a different approach like what you're suggesting potentially. All right, so take this. just need to define our seed number. And then let's see. I guess we just call it. So what we'll do is I will. Where does the value end up? Seed, initialize seed to any value except 0 before the first call. Oh, so it stores the value into the seed itself. Okay. So like we should be able to, we're just going to do some tests. I'll put it into the loop where we're initializing the memory. Oh no, I got to do it after that. Never mind. It's our clear mem here. So let's load A with just a number. Store A seed. A 19 store A seed plus 1, and then we'll call it a few times and see what it does to seed, just to make sure it seems to be working. Do 140. Oh yeah. And we can even see if we want to just take like a bit off of it and see if that kind of makes things more interesting even still, rather than using the whole number. So seed, where's the location of that actually? It is at BB. So we've got our value there. And we're just going to see what this does to it. So it changed it from 4121 to 24,850, and then 57,954, and then 4,083. So that is pretty kind of all over the place. 6306. Now, if I remember right, what's good about this is that it's repeatable based on the seed. Like we're gonna hit the same sequence. 6112 E262, right? I think that was the same. 6112 and then E262. Let's see. Yeah, cool. All right, so that's good. So it's random, but it's not totally random because the seed is the same and it's a deterministic function, it looks like. So basically, with different seeds, you get different random values, but it's always the same sequence of random values, which is what I want. That said, the next question is, what bit should we use? Maybe we'll just use the first bit in our processing of the repeat scroll. So right now, the background loop meta tile is loaded from our level data. So I want the same sequence because when it's truly random, if something breaks, it becomes really difficult to fix. Whereas if it's randomized with a sequence that's repeatable, it's easy to reproduce and actually like figure out what's going on. At some point, we might actually want it to be random, but you can imagine where different people playing the game, if it were really random, 100%. They would get different repeat tile sequences visually, which could be a good thing. I don't know. Like, I'm not sure. It seems like it's probably interesting, but not what I want, because I want it to be consistent across playthroughs. There might be some reason to want to be able to make it truly random by using something on the cartridge, or the ROM itself gets changed for each one we burn, or something where it's different, and that might impact the game. But that sounds like potentially a nightmare, where we have hidden edge cases that we didn't test, and as a result, the game is broken for some people but not for others. And that's the issue with true randomness, right? Is like that you'll never know what will come out of it. And it's hard enough with just random player input to, find all your bugs, but with true random data, it's really difficult. The other thing is if we want to do some sort of like a tracked sequence where we have the game play, and we have quote unquote randomness in the game. It's really, really hard to build one of those when there's actual random data being generated, because then whatever you record could potentially break. Yeah, that would be interesting. Like, have some way where a player could determine the randomness of the game by doing something that would affect the seed. That's definitely an interesting idea. For now, I want it to be consistent, so I'm just gonna leave it. But that's the reason why. So level data, we have our meta tile is 3, and that, if we look at the tile viewer, well, let me hit start here. I just wanted it to populate the tiles with the right palettes, because it doesn't know what the right palettes are until it's kind of hit them in the emulation. So this is being really random sounds difficult on the NES, but maybe could have a seed based on the frame. Yeah, there are definitely a number of factors. Like, we could also do something where, again, to make it somewhat predictable, you could do something where, the player could enter some sort of like really small passcode that is actually generating the seed for the randomness, and have that affect the game mechanics somehow. I'm definitely open to exploring possibilities like that, because it sounds really cool. But for now, just want this to work and work consistently, so that I can build more of the levels and stuff like that. So that's where I'm at. I might change the map structure to load the repeat scroll section first. Although this map section isn't that long. I'm just testing out what it's going to do if I say, okay, so that's tile 1. was just trying to figure out what it's... Okay, so tile 1, tile 2, tile 3. Okay. That's what I thought. So what I need to do, I think, is specify... I really don't want to change... What if I put tile 0? I think that might just be... Oops. An empty background. I didn't want to have to specify an additional byte for... Like, this is the non-drawing tile. Sorry, I'm just closing all the auxiliary windows here because they tend to slow messing down. So 0 is a tile with a dot. Is it that tile? What tile is that? Tile index 0. Oh, it's that. Why does that have a dot in it? It shouldn't. Where did that dot come from? Is that in my title screen? Is that being loaded? Is it like that in the beginning? No, I don't see any other color in that tile. Tile index 0. Although, oh yeah, it's not set. Is that just because of... That's goofy. So it's writing something into... It's writing something into the tile memory at some point. That's bad. We'll have to figure out what's doing that. All right, so what it really seems like I want to do, just for the sake of not messing with this too much right now, is just be like, okay, this is our on tile and then this is our off tile. So like, just means we're adding another byte to this definition here, which isn't terrible, except now the code is going to be, we just have to find where it is loading that byte and add code that we're VG meta tile. Find where we're actually setting that up. Oh, I see. Okay. So that's setting the position of our lookup. That's okay. It's just our one byte here. So we actually want to just do this and make it 2 bytes because we're then updating ROMEM to reflect that. Okay, I think that was all it needed, which is pretty good. Let me put a comment here while I'm here. Lookup is 2 bytes, so skip past both bytes to get to beginning of next section, hence the double Y increment here. make sure this... Make sure this isn't doing anything goofy here. Yep, okay, cool. So now we have two possible values. We have the background lookup tile index 0, and now we have 1, which is the other tile that we want to, the other meta tile that we want to use. Now, the only other thing is that, let's see, based on I guess I can get rid of all of this stuff here. Excuse me. Because this is all working without it now. This was all... Oh, this was the attribute code. Oh, right. Well, I'm just going to leave this. I don't want to even think about attributes right now. So how are we determining which row we are looking at? Temp has our base offset, clear carry, add BG tile, transfer A to Y. So that's our lookup into the, that's our base tile offset plus Y, and then we're going to do an exclusive OR. Where was BG tile set? So I assume that this is, okay, so this is being reused every time. So the only thing that's going to mess up this idea is that because we don't render the entire meta tile all at once, we need to know which meta tile version we're rendering at any given time, because then otherwise we will render partial meta tiles. Because right now what we're doing is we know what our offset is supposed to be based on this, and then BG tile, I guess we are updating it to flip back and forth between, yeah, so we're using this to flip back and forth between either the first or second tile on a particular row of the meta tile, and then based on, yeah, and then we're also flipping bit 2 to determine the row. So so we would have to switch BG, what is it, BG scroll meta tile or something, whatever that variable is. Where are you? BG loop meta tile, which is technically 0 all the time right now. Oh, you know what? Actually, that's not that bad, because the logic here is processing this BG tile thing. And so when it's 0, then we know we need to alternate between whatever current BG meta tile it is and the other one. Oh, but that's only if we're doing alternating. Yeah, that doesn't work for if we're doing random. Oh, but you know what? It does work because it lets us. Yeah, that does work because if it's equal, then we know that we're done rendering the tile, so we can do the random calculation and determine if we want to change, or we can even use that number that we get to determine if we're using 0 or 1 for the BG loop meta tile, which is the only value it can be, because the actual tile there, or the actual meta tile it's using, is based off of what's in the level data. So if it is equal, we're gonna skip the jump to skip repeat attribute update. So this is where we can do this. So jump subroutine to the random number generator, and then load A with seed, and then we're going to AND it with 1, and then branch if equal. So if A is 0, we're going to skip this part, but if A is 1, we're going to do load A BG loop meta tile exclusive OR it with 1, and then store it back into BG loop meta tile. Oh no, that's not what I wanted to do. That's actually more work than what we need to do. We can just say we're going to AND it with 1, so it's either going to be 0 or 1. We don't even know what it's going to be. It'll be based on whatever the number is, and then we're going to exclusive OR BG loop meta tile against that, and then we're going to store it back in. So based on whether it is 0 or 1 in the first place, it will flip whatever BG loop meta tile is. So let's see how that actually ends up looking. Could be interesting. Could be total crap too. We'll see. Interesting. So it's actually pretty... You're getting like these... It is random-ish, but you're getting consistently across an entire row. Yeah, and that makes sense, because we're determining for the entire row, aren't we? We're doing the bottom of the meta tile, and then we're doing the top of the meta tile, and then once we're done, we then have to flip everything back for the bottom of the meta tile, and that's when we're doing the random number calculation to determine, and then it just stays there and does that for all of them, which isn't what we want. What we want is actually way more complicated now that I'm really thinking that through, because let's go back for a second. I guess I should have thought of this. Should have thought this through a little bit more carefully. So what I was really thinking was, like, when we do this, or what needs to happen, which we're not going to do because it's too much storage to determine, is like I was thinking, okay, we're going to render this, and then we'll render this, and then we'll render this, and then, we'll determine for the next meta tile what it should be. But really what we're determining is what is it for the entire row. And in order to do it for the individual meta tiles across the row, we'd have to know what each of them was, which means we'd have to be storing 16 bytes of data just for each row that we're currently processing, which is more expensive than it really needs to be for something like this. I'm wondering if we could get away with I mean, you could go crazy and literally just do something like this, right? And just every time through. Yeah, I mean, it is and it isn't, right? Like, because we've got to process it outside the ROM, which is very easy to do, but then we've got to write the code to load those strips of data. And, you know, part of the reasoning behind what I was doing here was to save space. So while it definitely is less expensive than having a full map, it is not quite as efficient as I was hoping for. How did that break in this way? That is something else. And again, I'm not saying that your idea is not good or that we wouldn't investigate it. I think it definitely has the idea is an interesting one and worth potentially investigating if this ends up being a really poor implementation. I don't know if space is going to be scarce. Like, we've talked about this a little bit, and when I talked to Felipe about it, he was concerned a little bit about space usage with the way I was doing things. And what is the name of the tool? It is... I mean, yeah, there is definitely... So, like, our main program bank here has about a kilobyte free. We have four banks. But at the same point, what is this? This is BN-ROM, I think, that we're using here. And I think you can have way more than that. 128K at 32K banks. This could be just down to the configuration I have set up here right now. Like my ROM 0. So 2000 hex is 8K. $32, that's 8,000. So it starts at 8,000. The size is just about 8,000. Why is this showing mapper 34? Am I not using mapper 34? It is. Yeah. So why? That's interesting. I'm not sure why it's showing my bank sizes are only 16K. Is it the header? It could be the header. Oh yeah, so that's probably why. Let's see. Let's mess around with this for a second. So units in 16K units, size of program. So I mean, this is wrong. If we're saying that it's 128K is the maximum, right? For BNROM, and that's 816K, but I have 4 here for some reason. So let's build that. Okay, so that fixes that, right? So that's all of the program. Again, it's showing it in 16K chunks, but for BNROM, the program is actually 32K. Looks like you can even get 512K. So there's definitely a lot of space left. But the thing is with, when you have multiple banks, it obviously starts causing some challenges with your code. Well, no, the banks themselves, the 16, let me think about that, because actually I don't know. I thought that it could address 32K. Because the 64, it's a 64K address space, right? So cartridge space is 4020 to FFFF. If we look at that, that size is BFE0. So what is that actually in decimal? That's 49K, roughly. So it should be able to address 32K. Let me reopen my config file. So it starts, my ROM 0 starts at 8000, which means that we're actually starting a little bit further up in the address space than what's showing here, but I think that's because of what I thought that was because of what BNROM required. I'm confusing myself. This should be, yeah. So I'm starting at 8000, which gives me 32K of addressable space. I wonder if it's just this is assuming they're 16K. Is there anything else in the header that would tell it otherwise? There's no character ROM. It's all character RAM. And then the mapper is set. I'll have to ask about that. It could be a limitation of that tool, that it assumes they're 16K banks for some reason. Actually, what does Messen say? Program 64K. what? We got to reload this. Go away. Hello? Reload? Could not load. Why? Does it not like my header? Reload. Could not load file shooter NES. Oops. Tools. Edit INS header. Sing 64K. Mapper 34. If I open the debugger, does it tell me what the bank sizes are? Let's see. It says this is my code here, starting at 8,000. Yeah, that's true if you just do them as bits because we're alternating. That's a good point. I didn't think about bit encoding them, but you're right. That is a pretty efficient way of storing them in terms of the way that the meta tiles would need to be processed. All right, we'll look into doing it that way in a minute. What I really want to understand is two things. One is why Messin doesn't like why he doesn't like the header being bigger than. Does it have a limitation that it doesn't support the bigger INS headers for some reason? Or not the bigger INS header, but like in theory I should be able to do this. And then wait, where did it save that? Edit INS header. Save as. Oh, it saved it in. Saved it in there. That's not what I wanted. Then if I reload this. Oh, not that. It's fine, and still only says 64K though. Interesting. And let's look at the header and see if there are any differences. But no, you're right. That's actually a good idea. Storing it as two bytes is actually a really good idea. Just want to see if anything got changed. No, it looks like it's the same. So I wonder if that's just a limitation of Messin, that it doesn't like the header being so large. But okay, well, that's not really important to address right now. I was just curious about why that was happening. I was thinking about how large of an RPG overworld you could make if in an NES game, and wasn't sure how you'd find specific spots on a large map if you use run length encoding. Oh, like how you'd do anything where like if it's a big continuous world and not like screen by screen like Zelda, how you would index into it. I think you'd have to have some sort of way of... You'd have to have some sort of good way of... As long as the world was a fixed grid, you'd know what part of the grid you were in. But then the problem becomes like how... Yeah. I think that's probably the wrong data structure to use for a problem like that. Because the compression then becomes... I don't know. Or you could... I'm almost wondering if you could do... So this is totally just me thinking off the top of my head, so don't, like... What did everybody say? Don't at me. If this is totally wrong. Could you use like a binary space partitioning where you could use that to determine what goes where, and so the items, this is for spaces, that wouldn't work, but I was just thinking in terms of... Oh, thanks. Be more specific about what I'm doing is wrong, okay? And I said don't at me. Yeah, this is probably not what I'm looking for. I'm just thinking like in terms of the data that you'd want to, the way you'd want to store the data. It's almost like what you would want to do is you'd want to have something where it's like, okay, I know my world is, whatever size it is, and, we're going to subdivide it up into a grid space. And then, you're saying, okay, I'm here, so there's this data that represents whatever is on the map here, right? So this is your avatar here, and so you need to have this available. I mean, you know what? You could probably do it because of the limitations of the fact that you're 2D and you're looking down on it. Like, let's say worst case scenario. Well, no, let's say like all of these are a screen. That means, yeah, worst case scenario, you'd have all of these areas around you decompressed in some way, right? Where you need to be able to move to them freely. You could have the individual screens compressed, but you'd have them decompressed like this into like work RAMs so that you can scroll into them smoothly. Although 8 screens is probably a lot. And then the other challenge you have is as soon as you hit this one, you have to dump these and, hit these. And then if you traverse back, you've got it's like a waste of work to do something like that. So then the other way you could do stuff is, you could have it where I don't know. So you could even have something where you have your data structure describes where things are in space rather than being grid based. Like you say, here is a small section of something, and here is a small section of something, and they exist within these areas, and then you can determine what's within the bounds of that space based on where the player is and the grid that makes up the space. It's almost actually a little bit like conceptually similar to the idea of what they just were talking about in the Unreal Engine editor changes that they were talking about, where you could have different sections of the map that are all actually one total map, and then there are other sub pieces of the map that are stored in the same way. For tile-based games, I don't know how much sense that makes, though, because I feel like it would lend itself to really splotchy maps, right? Like you'd have to figure out a way to kind of make it look good in the areas where you don't actually have these like sections of detail. Well, yeah. I mean, it depends on how big your meta tiles are and stuff like that too. Like, with the size of cartridges being what they are and banking, you could probably get pretty big. I think I remember, I don't remember the exact number. I know Vectrix 28 was talking about how huge his world structure is with compression, and he's got some sort of crazy, I wish I knew off the top of my head, but it was something like enormous, like, I don't know, 32 screens by 32 screens or something like that. I might be completely making that number up, but I just remember everybody was pretty impressed with how big of an area he was, dealing with, and how efficient the compression was. So, no, I'm not really. I mean, I'm talking a little bit about scrolling in terms of like how that would impact the data structure you use, but the question was, if you're using run length encoding in your map, how would you then be able to find a random location and decompress that properly with run length encoding? You could probably do some math to run through the run length encoding process without actually decoding the... Oh, no, it's fine. You know what you could do potentially is you run through the encoded data without actually decoding into anything. You just look for, like how many... Yeah, that would work. So, like, if you know what X and Y coordinate you want to be in, right, then you could run through your run length encoded data. You could even include markers in your data to identify like the X and Y coordinate that they correlate to, so that you could expedite this process. But like, you find an X and Y coordinate marker that would encompass almost like a bounding box around your player in your run length encoded data, and then you could, when running while looking through it, figure out how much of it needs to be decompressed. It's definitely not trivial, I don't think, because there's a lot of math that you have to do to calculate, like, again, going back to my horrible diagram, if you ignore my idea here, it's like, okay, you've got all this data, and then like you've got these sections that are run length encoded, and you say, okay, well, this is one section, this is one section. I mean, there's going to be a lot of, each of those dots, or marks is like a section of a marker of different run lengths of data. And so you could identify like the X and Y coordinate in the map that is from, and then be like, okay, so I'm in this part of the screen, so I need to gather all of the data that decompresses into that, and use those markers to figure that out. That wouldn't be trivial, but it wouldn't be impossible. And then the bigger issue is, like, as you're scrolling, you'd have to be kind of keep doing that in order to make that work. So I think it's the wrong kind of compression to use for this scenario, but I'm happy to have someone explain to me in the comments or in the chat why my understanding is wrong. Just in the sense that I haven't really messed around with it that much to know. Like, that's part of the challenge. That's, like, my understanding is that's part of the reason why run length encoding is not so great. Like, it's okay for generally blocky content, but the compression isn't particularly good, and it provides you with challenges like this. So when we go to, oh, I know why. Because I didn't read the comments or include them. So I know why this is causing a problem. In my excitement of using this, did not bother paying attention to the fact that this call will do a couple of things. It returns a value in A, and it also modifies Y, which is a problem because I believe we are using both of those in this case. A, it's not such a big deal because, yeah, because we were messing around with that anyway, but Y is a problem because Y is being used for some other stuff we're doing. So transfer Y to A, do that, and then, and then push A, call that, pull A, transfer A to Y. Oh, crap. How did I do that? Okay. We don't actually want to do that yet. We want to do that here. Okay, so that's just an added expense to calling this. We need to preserve Y because we're going to use it later, like to do this, and if we change the value, that's going to be a problem. So let's see if that fixes the weirdness that we were seeing. Okay. Yeah, and Miralupa, don't worry about asking a question and that causing a sidetrack. Like, that's part of the reason why I'm doing it live, is for that interaction, so it's not a big deal. Like, that's, again, if I didn't want that, I wouldn't be doing it as a live stream, so it's all good. So this is behaving in the same way. I guess because we're populating the row. But this is going to get expensive to keep calling this. Right, because we're doing this in a loop for the tile. Where was I? Oh, but I was doing it in here. So it was doing it repeatedly. Is it just our number was not random enough? Oh no, I'm just not thinking about this carefully. So it is... Alright, so this approach is obviously not thinking about this carefully enough. So the problem is every time we change what this is, we have to do the recalculation for our base offset, which admittedly that's either 0 or 4. So maybe... Oh no, that's because that's the actual tile value. So we have to do this here. It's just going to have the same problem now because we're just doing it earlier on, but it's still going to... It's the same problem because it's still not changing. Run length encoding. It's where you, if you have a long sequence of numbers that are the same, you calculate, you basically say, like if you got this, like this, where it's 22 ones, you record 22 1, like that, and you got however many, 7 2s, etc. So you can see it's a little bit more efficient to do it that way, but that only works well when you have a lot of repeated sequences or repeated values. If you have values that are different all the time, like this, that's actually less efficient to store in run length encoding because you have to store, 1 1 1 2 1 3 1 4. So you've effectively doubled the space. So for simple chunky data, it's fine, but for large, like it was used for images in some cases, and it was fine because image resolutions were so low at the time that it was acceptable. With modern, images on 12 megapixel cameras and stuff like that, or higher, you could see where the detail that's captured is too high, and so the run length encoding would actually be less efficient than just the image itself. So this isn't going to work because this is just doing the same thing. We actually would have to recalculate this every time. All right, this is just a bust, doing this approach to randomizing it. That's a bummer. That's because we load the whole row every time. About the only thing we could do is kind of randomize what part of the meta tile we're loading, reasonably well, without going into more complex data structures, or more larger amounts of data that we have to store to make this work. Yeah, I mean, for stuff that's, again, relatively, like, so for the title screen in the game, because there's a lot of just empty space except for the title screen, the tiles for the title, it's obviously a little bit more efficient to store a bunch of space, empty space here as, just a repeat of the empty tile. But if it were anything more complex, it would kind of lose its efficiency, more than likely. What becomes more efficient is using tiles that can be repeated so that you have fewer tiles, and then you can you have less data stored about the tiles themselves rather than the makeup of the tile screen. I mean, actually, you probably want to have both fairly well compressed, but there are different trade-offs you can have based on what compression, what you're trying to save space on. In this case, because the tiles actually take up the prog ROM data, because we're using character RAM, it does make sense to be more efficient than you might otherwise be with tiles if you think you might have too many tiles in your program ROM, or you would have not enough space to fit it all into the 8K of the character RAM. So, all right, so that doesn't really leave us in a place where we made that much progress with the repeat scroll in terms of making it look a little bit more interesting. Miralupa, you're probably right that piecing together random strips of tiles is a better option, since that's really, like, realistically that's what it ends up being anyway, right? Like, if I'm not hard coding what those strips are, then I'm using RAM to calculate them. And then we're talking about wasting a lot of RAM to keep track of what meta tiles were used for these background rows. Although, actually, now that I say that, your idea of using 2 bytes is probably applicable here too. We could use 2 bytes to just keep track of if it's 0 or 1 for the 16 bits of the row. Right? So every time we go into a new row, we generate the 2 bytes that are used for tracking what meta tiles are used across. So we could do that. Not tonight, because it's already been almost 2 hours, because I spent too much time trying to fix that dumb rendering bug on the title screen. But I am wondering if I should give that a try. Because again, I was thinking about it in terms of bytes, but since we're only dealing with 2 possible meta tiles, then we could easily use just 2 bytes to represent the 16 tiles we need to. All right, let's do that Monday, because it's late. I'm tired. So, any other questions or anything before we wrap here? I don't think so, because I think the functional value could be. Yeah, no, that's true. It's maybe better to just leave it for now. But what I was going to say is, like, we do have the ability in the meta tiles to encode collisions, but I don't anticipate that we would do anything like that in the repeat scrolling. And so, so for, unless it was something like a large turret, it could just be done with a sprite, like being placed here. And then that sprite could be like a stationary sprite that you could collide with, instead of having to use the meta tiles for collision there. But yeah, you're right. Like, we probably wouldn't just have a random turret in the middle of the water. That would be something that we would kind of delegate to, or relegate to an actual map section, like, for here, for example. And then we could do that by just having just a strip of actual map like this, and then it ends here, and then that would be sufficient to go back to then the repeat scroll. So it's really more of an aesthetic thing that was bothering me, but you're right, it's probably better to stay focused on getting the map stuff done. I also have to, like I mentioned, the export process is not functional anymore because of the changes we made about the way that we're processing the game states. And we want to make that generated by the tool rather than hard-coded like I have right now. So, yeah. Perhaps the stripes could have a flag as to whether a turret or something. Yeah, that's possible too. There's a lot of options, but what I like about the approach that you were mentioning with the 2 bytes to represent the data, whether it's randomly generated in RAM or stored on data, is it's really efficient to do it. And if we wanted to encode anything else, we could use a similar approach with just another, set of 2 bytes to, we would probably want to limit what the possible options are there, because there's only so many things that you would want to have. And so, if we were talking about 8 bytes at the end of the day, that's actually not bad, and it's still fewer bytes than the 16 that you would need to represent a full 16 bytes for the entire row. Sometimes I'm still forgetting that and it comes back to because nobody wants to use bit masks anymore, I've just kind of gotten out of the habit of using them, but they're so much more efficient to store stuff. So 16x water stripe doesn't have the turret flag. Yeah. Yep. And then we could even do something like there's just one additional byte that specifies what 2x2 section of the strip has the turret. We could, be even, because it doesn't have to be down to each individual meta tile. It could be one of, it could be we could further subdivide it if we needed to. So yeah, that's really good. That's good ideas there. So we'll look into that later. Probably just leave this alone, but I will remember that for when we come back to this, or if we have to supplement this section to do this. But eventually we'll need to come back, because it's just I don't like how repetitive it is right now. But okay, cool. Some languages don't bother doing things at bit level. Booleans are full byte. Yeah. Oh yeah, for sure. I'm pretty sure Java is a full byte, for example, only because I distinctly recall having a conversation with a colleague at a former company who was so proud of all the space he was saving by using a Boolean in Java, only to be dismayed at the fact that it was actually a byte and full 8 bits. So anyway, yeah, he was using this giant array of Booleans, thinking that he was saving space. Never bothered to actually check the size, though. Well, as always, thank you for tuning in, joining me live. I appreciate it. You can always find me on Twitter at Clairvis. You can find the recording of this on YouTube, and you can feel free to comment or ask questions or subscribe or any of those things. And yeah, if you want to find me, my email is zelius@gmail.com. You can also find me on Discord as Zelius at Video Game Sage or Clairvis, pretty much everywhere else on Discord. And looking forward to Monday and making some more progress on the level. And I hope you all have a very good weekend. Thanks again for joining, and I will see you next time. Bye.